Algorithms for problem solving. Learning objectives. In this chapter, the user would learn the following in detail. Exchange values of two variables, summation of a set of numbers, decimal base to binary conversion, reversing digits of an integer, GCD, greatest common division of two numbers, test whether a number is prime, organize numbers in ascending order, find square root of a number, factorial computation, Fibonacci sequence, evaluate sin x as sum of a series, reverse order of elements of an array, find largest number in an array, print elements of upper triangular matrix, multiplication of two matrices, evaluate a polynomial. Problem definition. Exchanging values of two variables. Analysis. Two variables x and y contains two different values. Swap the values of x and y such that x has y's value and y has x's value. Solving by example. Let us consider two variables x and y containing values 8 and 20 respectively. The original values of x and y are x8, y20. The requirement is once the algorithm is performed, the results should be x20, y8. If you think by just saying x is equal to y is equal to x, the value gets swapped, then you are mistaken. These instructions are atomic in nature and hence x is equal to y means that the value of x is lost. So we have to use a temporary variable temp to store the value of x. Temp is equal to x. Temp 8, x8, y20. X is equal to y. Temp 8, x20, y20. Y is equal to temp. Temp 8, x20, y8. The value of x and y is swapped. Algorithm definition. Step 1. Start. Step 2. Get the values of x and y. Step 3. Store x's value to temp. Temp is equal to x. Step 4. Store y's value to x. So x has y's value, now x is equal to y. Step 5. Store temp's value, the value of the old x in y. Step 6. Stop. Example, program 4 to exchange the values of two variables using a temporary variable. Output. Summation of a set of numbers. Problem definition. Summation of a set of numbers. Problem analysis. Given a list of n numbers, the algorithm should add up the n numbers to find the sum of these values. Solving by example. Consider a list of 5 numbers 5, 8, 7, 12, 15. The algorithm takes the numbers as input and should produce the output as 47. Algorithm definition. Step 1. Start. Step 2. Get the values of n numbers that need to be summed up. Step 3. Initialize sum to 0. Step 4. Initialize I to 1. Step 5. While I is less than or equal to n, do the following steps. Read the ith number. Add the ith number to the current value of sum. Increment I by 1. Step 6. Print the value of sum. Step 7. Stop. Example program for two summation of a set of numbers. Output. Decimal base to binary base conversion. Problem definition. Decimal to binary base conversion. Problem analysis. A number with base n will contain digits from 0 to n minus 1. Hence, decimal base system is H. Usual number base system, which we use in our normal, contain digits from 0 to 9. For example, 922 base 10 is a number with base 10. A binary number system has a base 2. Hence, it uses just one numbers, that is 0 to n-1. The computer system stores information in the binary number system. The conversion of decimal number to binary number is done by dividing the decimal number by 2 repeatedly and by accumulating the remainders obtained till the quotient becomes 0. The reverse of the accumulated remainders is the binary equivalent, the decimal number. Solving by example, consider the decimal number 18 to the base 10. Quotient, remainder. Quotient 18 dividing 2 is equal to 9, remainder 0. Quotient 9 dividing 2 is equal to 4, remainder 1. Quotient 4 plus 2 is equal to 2, remainder 0. Quotient 2 dividing 2 is equal to 1, remainder 0. Quotient 1 dividing 2 is equal to 0, remainder 1. Reverse the remainders to obtain the binary equivalent. Hence 18 to the base 10 equivalent to 1010 to the power of 2. Algorithm definition. Start. Read the decimal number n that has to be converted to binary. Initialize b into 0. Initialize I to 0. Repeat the following steps until n is greater than 0. Dividend by 2. Store the quotient to n. Add the value 10 asterisk remainder to the value I binary. This part will take care reversing the accumulated remainders. Increment I by 1. Print the value of bin. Stop. Example program for to convert a number from decimal base to binary. Output. Reversing digits of an integer. Problem definition. Reversing the digit of an integer. Problem analysis. Given an integer number a, b, c, d, say 1, 2, 3, 4, where a is equal to 1, b is equal to 2, and so on. The algorithm should convert the number to DCBA. Solving by example. Consider an integer number 7823. The reverse of an integer number is obtained by successively dividing the integer by 10 and accumulating the remainder till the quotient becomes less than 10. Accumulated remainder, quotient 7823 mod 10, accumulated remainder 3, quotient 782. 782 mod 10, accumulated remainder 32, quotient 78. 78 mod 10, accumulated remainder 328, quotient 7. 7 mod 10, accumulated remainder 3287, quotient 0. The remainder of a division operation can be found out by the mod function. Algorithm definition. Step 1. Start. Step 2. Read the integer and to be reversed. Step 3. Initialize REV to 0. Step 4. Write n is greater than 0. Does the following step. A. Divide the integer n by 10. B. Store the quotient to n. C. Multiply 10 to the already existing value of REV. Add the remainder to the value of REV. Step 5. Print the value of REV. Step 6. Stop. Example program for to reversing digits of an integer. Output. GCD, greatest common divisor of two numbers. Problem definition. To find the greatest common divisor of two numbers. Problem analysis. GCD of two numbers is the greatest common factor of the given two numbers. GCD of two numbers is obtained using the following method. Divide the larger of the two numbers by the smaller one. Divide the divisor by the remainder. Repeat this process till the remainder becomes 0. The last divisor is the GCD of the two. Solving by example. Consider two numbers 188 and 423. The smaller number is 188, therefore divide 423 by 188. Step 1. 47, remainder becomes the divisor and 188 divisor becomes the dividend. Step 2. Since the remainder has become 0, 47 is the GCD of 188 and 423. Algorithm definition. Start. Read two numbers for which GCD is to be found, say A, B. Let A be the larger of two numbers. Divide A by B. Get the remainder of the division operation. Divide the divisor of the previous division operation with the remainder. Repeat steps 4, 5, 6 till the remainder becomes 0. The divisor of the last division operation performed is the GCD of the two numbers. Stop. Example program for to compute greatest common divisor of two numbers. Output. Test whether a number is prime. Problem definition. To verify whether an integer is prime or not. Problem analysis. Prime number is an integer which is exactly divisible by 1 and itself. For example, 17 is a prime number because 1 and 17 are the only two factors of 17. Generalizing this, a positive integer with two factors is a prime number. Examples of prime numbers are 2, 3, 5, 7, 11, 13. To verify whether a number, say, is prime or not, divide the number by 2 to n minus 1. If the remainder is 0 in any of the cases, then the number is not prime. Such numbers are called composite. Mathematically, it is also enough to divide the number from 2 to the power of n. Solving by example. Let us take two numbers 37 and 49. Consider 37 first. The square root of 37 is 6 approximately. Now divide 37 by 2, 3, 4, 5 and 6. None of the division operation gives a remainder of 0. Hence 37 is a prime number. Now let us consider 49. The square root of 49 is 7. So let us divide 49 by 2, 3, 4, 5, 6 and 7. As 49 is divisible by 7, it is not prime number. Algorithm definition. Step 1. Begin. Step 2. Read the number n which we want to verify whether prime or not. Step 3. Initialize the value of the divisor I as. Step 4. Repeat the following step still I less than or equal to square root of n or the remainder of the division operation is 0. Divide n by I. If remainder is 0, then print the number is not prime and exit the process. Step 5. If none of the remainders are 0, print n is a prime number. Step 6. Stop. Example program for to check if the given number is prime. Output. Organize numbers in ascending order. Problem definition. Organize a given set of number S in ascending order. Problem analysis. The process of organizing a given set of numbers in ascending descending orders is called sorting. Though there are different flavors of sorting algorithms, selection sort is the one that is widely used. Selection sort involves identifying the smallest number in the array of numbers and placing it in the top of the list. Then the second smaller number is identified and placed second the list. This process continues for n number. Solving by example, consider the given array. Unsorted list. 122, 215, 307, 412, 509, 617. Identify the smaller element in the array. The element at position 3 is the smallest. Swap the elements at position 1 and position 3. The array becomes 107, 215, 322, 412, 509, 617. 07s are sorted. 15, 22, 12, 09 and 17 are unsorted. 07 is identified as smallest. Identify the second smallest number at position 5. Swap the element at position 2 and position 5. 107, 209, 322, 412, 515, 617. 07, 09 are sorted. 22, 12, 15 and 17 are unsorted. 09 is identified as the second smallest. Various snapshots of the sorting process is given below. Snapshot 3, 107, 209, 312, 4, 22, 5, 15, 6, 17. So 3 and 4 are swapped. 07, 09 and 12 are sorted. 22, 15 and 17 are unsorted. 12 is identified as the third smallest. Snapshot 4, 107, 209, 312, 415, 522, 617. So 5 is swapped. 07, 09, 12 and 15 are sorted. 22 and 17 are unsorted. 15 is identified as the fourth smallest. Snapshot 5. 107, 209, 312, 415, 517, 622. 6 swap. Everything is sorted. 17 is identified as the fifth smallest. Example, program for to organize numbers in ascending order. Output. Find the square root of a number. Problem definition. Find the square root of an integer. Problem analysis. Square root of a given number n is that natural number which when multiplied by itself produces a product of n. For example, 2 into 2 is equal to 4. So 2 is the square root of 4. 3 into 3 is equal to 9. So 3 is the square root of 9. So if m is a square root of n, then it can be derivated that m into m is equal to n and added symbolically denoted by square root of n is equal to m. Solving by example. There are two ways of finding the square root of a number. The first one is the trial and error method, where we can zero up on the square root by multiplying different numbers to itself and deciding on the number which produces the nearest result. Another method is a bit complicated. For example, let us consider an integer 625. Now place approver every pair of digits starting from the right. The number of bars indicate the number of digits in the square root. We can divide 625 as 6 bar 25 bar. Now find the largest square root of the first pair which is equal to or less than the first pair. Take the square root of this number as divisor and derive the quotient. Subtract the first pair of numbers and bring the next period down. 2, divide 625 by 2. 2 into 2, 4. So the remainder is 225. Now double the quotient as it appears and leaves a blank digit on the right. This is the next divisor. The blank digit should be selected in such a way that multiplying the digit with the number formed as the divisor should be less than, equal to, or the dividend. For example, here 46 into 6 is equal to 276 is greater than 225. Hence, we select 5 as the digit which satisfies our condition. 45 into 5 is equal to 225. Put the digit to the quotient. Hence, the square root of 625. Example program for to find the square root of a number. Output. Factorial computation. To compute factorial of a given number. Input. Number whose number is to be computed is equal to greater than n. Output. Factorial of n is fact. Step 1. Input number whose factorial is to be computed, (n). Step 2. Initialize fact is equal to 1. Assign n is equal to m. Step 3. Check if m is greater than 1. Yes. Assign product of fact and m to fact. Decrement m. Repeat step 3. No. Output factorial of n is fact. Step 4. Stop. Example, to compute factorial of a given number. Output. Fibonacci sequence. To generate Fibonacci series for given range. Input. Range between which Fibonacci series is to be generated, low, high. Output, Fibonacci series. Step 1. Input range between which Fibonacci series is to be generated, low, high. Step 2. Assign A is equal to 0. Assign B is equal to 1. Step 3. If A is greater than or equal to low and if B is lesser than or equal to high. Yes. Output A. No. Step 4. Step 4. If B is greater than or equal to low and B is lesser than or equal to high. Yes. Output B. No. Step 5. Step 5. Assign sum of A and B to C. Step 6. If C is greater than or equal to low and C is lesser than or equal to high. Yes. Output C. No. Stop. Step 7. Assign B is equal to A, C is equal to B, sum A and B to C. Repeat step 6. Example program for to generate Fibonacci series for given range. Output. Evaluate sin x as sum of a series. Input. Number whose sine function is to be computed x. Number of iterations to be carried out n. Output. Sine of the given number. Step 1. Input. Number whose sine function is to be computed x. Number of iterations to be carried out n. Step 2. Initialize sum is equal to 0. Den is equal to 1. Step 3. If n is equal to 1. Yes. Output sine x is x. No. Step 4. Step 4. Initialize flag is equal to 1. Fact is equal to 1. Assign x is equal to y. Step 5. Add sum to flag multiplied by x divided by fact and assign to sum. Sum is equal to flag into x divided by fact. Assign the product of x and the square of y to x. X is equal to x into y square. Negate the sign of the flag. Compute the product of fact den and den plus 1 and assign to fact. Fact is equal to fact into den plus 1. Increment den by 2. Decrement n by 1. Repeat step 5 n times. Step 6. Output the sum. Example program for to evaluate sin x as a sum of a series. Output. Reverse order of elements of an array. Iterative way. Initialize start and indexes. Start is equal to 0. End is equal to n minus 1. In a loop, swap ARR start with ARR end and change start and end as follows. Start is equal to start plus 1 semicolon. End is equal to end minus 1. Recursive way. Initialize start and indexes. Start is equal to 0. End is equal to n minus 1. Swap array. Start with arr end. Recursively call reverse for rest of the array. For example, if A is an array of integers with 3 elements such that A0 is equal to 1, A1 is equal to 2, A2 is equal to 3. Then on reversing the array will be A2 is equal to 3, A1 is equal to 2, A0 is equal to 1. Example program for to reverse order of elements of an array. Output. Find largest number in an array. Problem statement. Design an algorithm to find maximum value among a set of n numbers. Solution. Algorithm name. Search max A n r. Input. A is an array, contains n greater than equal to 0 number of real numbers. Output. R will hold the index of the first maximum value in the array A. Step 1. R is equal to 0. Step 2. I is equal to 1. Step 3. While I is lesser than n. If A within brackets I greater than A within brackets R, then R is equal to I. End if. I is equal to I plus 1. End while. Step 4. Return. Example program for to find largest number in array. Output. Print elements of upper triangular matrix. Input, the square matrix of length n. Output, the upper triangle matrix. Step 1. The input, the order of the matrix, mxn. Step 2. Input the elements of the matrix A, open brackets, I, j, close bracket. Step 3. Initialize I, j. Step 4. Check if I lesser than rows and increment I, open bracket, I plus plus, close bracket. Step 5. Check if j lesser than column and increment j, open bracket, j plus plus, close bracket. Print A, open bracket, I, close bracket, open bracket, j, close bracket. Initialize sum is equal to 0. Check if I lesser than j, then sum is equal to sum plus a, open bracket I, close bracket, open bracket j, close bracket. Print sum, open bracket n, sum of upper triangle elements, close bracket, stop. Example. Add these elements in main diagonal for any elements a, I, j, I lesser than j, sum of the upper triangle elements 6. Example program for to print elements of upper triangular matrix. Output. Multiplication of two matrices. Given two matrices A and B of orders m into n and p into q respectively. This algorithm multiplies the two matrices and stores the result in matrix C of order m into q. I, j, k denotes array indices. Output. Algorithm of multiplication of two matrices. Number of columns in matrix A is equal to number of rows in matrix B. Loop for each row in matrix A. Loop for each columns in matrix B and initialize output matrix C to 0. This loop will run for each rows of matrix A. Loop for each columns in matrix A. Multiply A, open bracket I, k, close bracket, to B, open bracket, k, j, close bracket, and add this value to C, open bracket, I, j, close bracket. Return output matrix C. Evaluate a polynomial. The polynomial equation formula is P, open bracket, x, close bracket, is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2x to the power n minus 2 plus and so on plus a1x plus a0. Here is the source code of the C program to evaluate the given polynomial equation. The C program is successfully compiled and run on a Linux system. Consider the polynomial 3x to the power 4 plus 2x to the power 3 plus x to the power 2 plus x plus 2, where x is equal to 2, then the output will be as follows. Output. Enter the degree of the polynomial 4. Enter the coefficients into the array 3, 2, 1, 1, 2. Enter the value of x 2. Value of the polynomial is 72.000000. Example program for to evaluate a polynomial. Output. Conclusion. In this chapter, we have covered the following aspects of algorithms for problem solving. Exchange values of two variables. summation of a set of numbers, decimal base to binary conversion, reversing digits of an integer, GCD, greatest common division of two numbers, test whether a number is prime, organize numbers in ascending order, find square root of a number, factorial computation, Fibonacci sequence, evaluate sin x as sum of a series, reverse order of elements of an array, find largest number in an array, print elements of upper triangular matrix, multiplication of two matrices, evaluate a polynomial.